On a per unit basis, $100. The ratio is 40%. You can figure it either way. There's $40,000 in total divided by $100,000. That's 40%. You can take $100 per unit times $250 per unit. That's 40%. So it's in proportion. So now, how do you determine break-even analysis? Oh, that's what I love, because it's just taking that formula and dividing it so that, let me give you in my own handwriting. So in this example here that I've given you, we have total fixed costs of 100,000, or their total fixed expenses, same thing. We have contribution margin per unit. So I could determine the break-even point in units by simply taking the total fixed cost or fixed expenses and dividing it by the contribution margin per unit. Let's see how this math works. All right. We know the total fixed cost in this problem is $100,000. So let's put $100,000 in the numerator and divide it by the contribution margin per unit. That's that right there. So if we got dollars dividing into dollars, what are we going to end up with? 4 into 10 is 2. That's 8 minus 10 is 2, carries over. Now 4 into 20 is 5. So we got to sell 25,000 units to break even. Well, let's find out if that's accurate. What's $6 per unit times 25,000 units? What's $10 times 25,000 units? That'd be $250,000 in total sales, wouldn't it? What's $6 times $25,000? 150,000. Contribution margin is going to be 100,000. There's my contribution margin. Total fixed cost, 100,000. Did we break even? Did we cover all variable and fixed costs? We did. How did we calculate the break-even point units? There it is. Memorize the formula. Total fixed cost divided by contribution margin per unit. So we know we got to sell 25,000 units to break even, right? We can get the dollar sales by changing the formula around just a tad. So if we're trying to figure out the break-even point in dollars, we take the same numerator, total fixed cost divided by the contribution margin ratio or percentage. So we have $100,000 divided by 0.4. We have to move the decimal place over. That's $250,000, isn't it? So we got the break-even point in dollars, and then we got the formula break-even point in units. I like it because then I still take my total fixed costs in either way, but here's the key word, in units. So I need to divide it by contribution margin per unit to give me the total units. I want to know the break-even point in dollars. I got to use the contribution percentage or contribution margin. That one I have to kind of memorize. Oh, but it's not hard. You got one of two choices here. Are we trying to find the contribution margin per unit? Some problems will give you that. If the question says how much do you need to sell to break even, you can convert this into 4 divided by 10. Your contribution margin is 40%. Your variable expense percentage is 60%. And your sales is always 100%, 10 divided by 10, 6 divided by 10, 4 divided by 10. You get the math? It's not hard. But for me, being a math major, it was a piece of cake. For most of you, these numbers are easy, I think, to understand. So I memorized these two shortcut equations. You got the break-even point in units, break-even point in dollars. They both start with total fixed costs. The denominator is different. If we want dollars, we got to divide it by the contribution margin percentage. If we want to know the number of units to break even, we divide it by the contribution margin per unit. Any questions on those two formulas? That's one of 5 sets of formulas that you'll memorize. Now, the next set of formulas is pretty simple because it's based on a targeted profit. And if we want to follow the textbook, they show their example, break-even analysis. The equation method, that's one way. The other method, have graph paper and you can figure out the break-even point. But I prefer the formula method. Units sales to break even. Units, how many units? It's going to be the total fixed expenses divided by a unit contribution margin. Break even in dollar sales. Oh, dollar sales, fixed expenses divided by contribution margin ratio. All right. Now, the next set is adding a targeted profit to the numerator. To the numerator. So let's say in that problem, we're going to keep these numbers because they're simple numbers. We got a selling price of $10. We got variable cost of $6. Get a contribution margin per unit of $4. And our total fixed costs, we still have $100,000. And so you're contemplating if, you got this idea, oh, I can manufacture this. I can easily get $10. Here's what my variable costs are. Here's the contribution margin per unit. I can determine I'm going to need to sell 25,000 units. So question number 1, can your operations produce 25,000 units? If it can't, then you probably aren't going to go into business, right? So then the next question you ask yourself, do I want to do all this work for, how much money am I willing to make? Right now, I got a salary position making $60,000 a year. And you might say, okay, in order for me to do all this work, I want to have at least a targeted net income or targeted net operating income of $100,000. No, let's go. That's with inflation, that's nothing nowadays. You go, I want to make $200,000 a year if I can. I'm not going to go into business. So what you do is you take those two formulas and it's saying with this targeted net income, how many units would you have to produce? How many units would you have to sell? All right. If you want to know how many units in dollars, if you're just looking for the number of units you need to sell, you take the $200 you want as your targeted net operating income and you add it to the total fixed cost. That's all. That's the only thing that changes. You had fixed cost totaling $100,000. You want to generate $200,000 in net operating income. Well, if I want to know the unit that I need to sell in dollars, then I need the contribution margin percentage. So I can divide it by 40% or 0.4. If I want to know the number of units, my numerator stays the same, 200,000 targeted net income plus total fixed costs of 100,000, and cost per unit is $4 per unit. And I do my math here. I got 300,000 divided by $4. How many units would I need to sell?
75,000.
75,000? How many total sales dollars do you need to have? Would that be 750,000? I didn't do the math, not dividing it. I know when you have 300,000, then you have to move the decimal over. That's 3 million. 4 into 3 million, that's going to be 7. That's 280,000. That carries another, that's $750,000, isn't it? You also could just simply take, hey, what is my number of units? Multiply it by the selling price per unit. So $10 times 75,000 units, that'd be $750,000. Can get it more than one way in math, can't you? So can you easily memorize these formulas when you're looking at a target in net income? You can determine the sales dollars, and you can determine how many units you need to sell. Am I right? It's just a variation of what we just went over on the break-even analysis equations. Any questions thus far? Is it too simple? I think it's pretty easy, this part of the chapter. Any questions before I continue? So the next part of the chapter looks at the margin of safety. The margin of safety is simply how many units are you above the break-even point? But the margin of safety is always in dollars. I mean, if the question asks for the margin of safety in dollars, you take either your actual or your budgeted sales, depending on the situation, and you subtract it from the break-even sales. And on page 213, they have sales of 100,000. That's their break-even, isn't it? Margin of safety. Oh, so the break-even. Oh, they had break-even of 87,500, and the sales for the current volume of 400 speakers. Let's see if I can get it all on the screen. Can you see that? So here's what their currently sales are at minus the break-even sales. So the margin of safety in dollars is 12,500. And to get the margin of safety as a percentage, you take your margin of safety in dollars and divide it by your current sales dollars, or if this was a budget, your budgeted sales. So margin of safety in dollars, margin of safety as a percentage. That isn't that difficult for people like you. I wouldn't think either. Just we have subtraction and then division. Any questions on margin of safety? Star it. You're going to need to know how to do it besides the other formulas. And then let's see, the next one, I think, is the degree of operating leverage. The degree of operating leverage. So there's another one you're going to star. What is the definition? Degree of operating leverage is simply what's our contribution margin divided by the net operating income. That's going to be the degree of operating leverage. The higher your fixed cost, the higher the leverage. The higher the leverage. The smaller the fixed cost, the less the leverage. So they have two farms, Bogside Farms. Their contribution margin in total was $40,000. Their net operating income was $10,000. So you divide the contribution margin in dollars divided by the net operating income in dollars, and they have 4. So if Bogside Farms has a 10% increase in sales, they'll get a 40% increase in net operating income. But look at the Sterling Farm. They have a much higher degree of operating leverage. Their operating leverage is 7. How did they arrive at it? They took their contribution margin in dollars divided by the net operating income in dollars. So their degree of operating leverage is 7. So if they can increase their sales by only 10%, it'll have the effect of increasing their net operating income by 70%. So you take the degree of operating leverage and you multiply it by the increase in sales. That's why car dealerships, they have high fixed costs. That's why at the end of the month, they're just trying to get all their salespeople to sell just a little bit more, and it's going to increase their net operating income by a large margin. All right. Any questions on that? Again, the math is really not that hard. Hardest part might be memorizing. Oh, degree of operating leverage. I always take my contribution margin divided by my net operating income. All right. I think that might be the last formula. Now, the last item in the chapter has to do with sales mix. Oh, this is important. Look at, I circled it and highlighted. What's the term mean? So understand what it means. Sales mix refers to the relative proportion in which a company's products are sold, the combination or mix that will yield the greatest profits. Hence, profits will depend to some extent on the company's sales mix. Profits will be greater if the high margin rather than the low margin items make up a relatively large proportion of total sales. Try to wrap your arms around those statements, but it's much easier if we go over an example. Sales mix and break-even analysis. They go through this problem here. And let me see, do I have an example or do we have to use their example? Where did I do with problems? Here it is. So this problem relates to all those other formulas. Problem 520. And then exercise 5A3. So we're going to go into the appendix in this chapter. But let's see if I have, like, let me go one more place to look for an example. So we have problem 523. It's an application on contribution margin ratio, degree of operating leverage. Oh, that's problem 523. 5-25, changes in fixed cost, variable cost. That's a good one. And then I think there's one more for homework. I think it's on a sales mix. Maybe it's an exercise. Maybe it's an exercise. Is there another problem that I assigned in the assignment tool for chapter 5? Degree of operating leverage. Somebody take say the problems that we have to do. We have to do problem 5-21.
Yeah. 5-23.
Oh, that was that one. 5-25.
Yeah.
There's the monthly break even.
And also P5A-7.
Yes, that's in the appendix. That's in the appendix. Okay, I thought we had one. Here, let me look one other place. Hang on. All right, let me check the time, 1:34. So let's go over the two problems I have here, and then we'll have to go back to the sales mix problem. And we're going to probably use that example out of the book. But instead of cluttering your mind with other new material, you got enough new material that you're going to put together on problem 5-20. So let's go to page 232. Page 232. Let me see here. That's that's why. There it is. That's the homework. Now where's my problem? I just had it, I thought. All right, 520, cost volume profit applications. Northwood Company manufactures basketballs. The company has a ball that sells for $25. So get a piece of paper out and show me the contribution margin. What's our selling price? Is that important? Oh, it is. You have to know your selling price if you're trying to find break-even point. So the very first requirement, it says compute the contribution margin and the break-even point in balls and the degree of operating leverage at last year's sales level. So what are we going to need to know? We're selling each basketball for $25. Do they give us the variable cost per unit? Tell me if you can see that.
I'm sorry, what problem are you on?
5-20. 5-20 on page 232. Do you have your textbook with you?
I do. I'm on it.
Okay. All right. So selling price is $25, right? What do we need to know to get to contribution margin? Clarissa? What's the formula to get the contribution margin?
Contribution margin.
How do we get there? Stu, didn't I go over that?
Yeah, I think we would subtract the $15 from that.
Oh, so you subtract the fixed costs or fixed expenses. This is on a per unit basis, right? So I can identify, oh, $25 selling price per unit. Variable expenses are $15 per unit. Then I get my contribution margin of $10 per unit, right? So what's the first question? Compute the contribution margin ratio. How do we calculate the ratios here? Is 25 divided by 25, is that 100%?
Yeah.
Greg, what would be the variable expense ratio?
15 divided by 25,
Which would be what? 15 divided by 25. You have your calculator?
60%.
So then your contribution margin, $10 divided by 25. Craig, what do you get?
40.
Oh, yeah, you didn't even have to do that. You could subtract 60% from 100%. You get 40% as well. You could do it more than one way in math, can't you? Is Paige cold today too? Did you get any snow in Paige?
It's cold. It's windy. But
Windy.
There's no snow.
No snow. That's probably disheartening for you. You wanted the lake to be frozen so you can skate on it today. Has that lake ever frozen?
No.
It hasn't. Doesn't get that cold. It's a shame. Back in Ohio, we used to always go skating on the pond had hockey games and that kind of stuff. And then one time I fell through the ice. Luckily, it was just one leg fell through the ice. Oh, it was cold enough. I couldn't even imagine my whole body going into that icy cold water. But I got a good feeling of how it must feel like when I was going down the Grand Canyon and the water was 40 degrees and the boat flipped everybody out into the water. That was cold. Anyways, let's get back to accounting. It's more exciting anyways. Though it's pretty refreshing when you jump into 40-degree water. You're going to be awake. So now, can we use any of the information that we have on paper now to come up with the break-even point in balls? How would we do that? That would be units. That we would use that formula for units. What was that formula? Was it total fixed cost divided by the cost contribution margin per unit? Does this give us the break-even point in units? Did I remember the formula? Break-even point in units. Take your total fixed cost. Did they give us total fixed cost here, Greg?
$25.
$25. He says, Vanessa, are you going to jump on that bandwagon?
Oh,
That
it's
bandwagon?
750,000.
Oh, that's a big difference.
Yeah.
So you're saying fixed costs are 750? Vanessa, are you still with us?
I am. I'm
Yeah.
following.
Are you going to agree with them? 750,000 is total fixed cost? She's silent. Clarissa, how about yourself? 2 people got on that bandwagon. Are you going to jump on board? Wait, I can't hear you. Don't tell me you're having problems with the mic again.
210?
210. That's a lot less than Greg saying 750,000.
The total fixed cost.
Oh, is that what the formula says here? Greg, can you see this on the screen? What's TFC stand for? TFC.
Fixed cost.
Total fixed cost.
Yep.
And you said 750,000 you were plugging in there. What was going through your mind?
I don't know.
It was probably the wind making it too cold for you to think straight. So it should be 210,000. Try plugging it into the formula. 210,000 is total fixed cost divided by the contribution margin per unit. How much is the contribution? What is it, 10? And what do you get, Vanessa? What do you get? How many balls?
21,000.
21,000 balls or
Balls.
units, right?
Yeah.
We'll say units because that's the formula, break-even point in units. The units are in balls, so you could say 21,000 units or 21,000 balls, right? But the question asks, how many balls? 21,000. Stu, is this too easy for you? You need more.
Nope.
You
Right
need
on
more of a
track.
challenge. Okay.
So that's just A,
No,
right?
we're good.
Oh, we're not even done with A, Vanessa. We're not even done with A. Are we? For number 1, A. That is correct for A. But what if I asked the question, what's the break-even point in dollars, Vanessa? Then what would you do? What would you do?
Put a dollar sign in front.
Where would you put the dollar sign? Right in front of 21,000, you put a dollar
Yeah.
sign? No, that
Yeah.
would be wrong. That would be wrong. Wrong. You didn't use the formula. Break-even point in dollars is the total fixed cost divided by contribution ratio or percentage. So it's 210,000. Numerator's the same, but we're dividing it by the contribution margin ratio, which is how much? How much?
40%.
Yes, or convert it to a decimal, 0.4. Now what's that going to be? What's going to be in dollars? Or we could take 21,000 units times $25 per unit. Either way, go ahead and do the division. 0.4 into 210,000, that would be 2,100,000.
525,000.
Oh, so that's what we would have to sell to break even. Can we verify that? Let's take $25 per unit times 21,000 units. Tell me what you get when you have your calculator, your basic calculator. $25 times 21,000 units. What is that? Somebody quickly calculate.
525,000.
Oh,
Same price.
yes. Okay,
price.
there's total sales. What's $15 our variable cost per unit or variable expense per unit times 21,000 units. What's that going to be? Total variable expenses. What's that going to be? 21,000 balls we're selling at $15 are variable cost. That'd be 210,000 plus half of that. So that's 101. Would that be 315,000? Did I calculate that correctly?
Sounds
Who has-
good, but you lost me.
Well, somebody use a calculator and see if I'm right. 21,000.
That's what I got.
What did you get? 305,000?
315,000.
315,000. There you go. How did I get that? 210, 10% of, because $15, 10 times 221,000, that's 210,000. $5 is half of 210. That's 105. So that's 315. That's one way you can do it, or you could use a basic calculator, or you could do it the old fashioned way. So when we subtract this, do we end up with 210,000 as my total contribution margin? And then if I take my total fixed cost or total fixed expenses, how much is that?
I can't see your
210?
paper.
Oh, I see it. I
Push
see
your
it.
paper up.
Can't you see that now?
No, yeah,
So
a little more.
that's break even point. Break even point. I confirmed a break even point. Oh, did you see how I did that? I did it the long way to confirm it. Oh, yeah, you did have to sell 21,000 units to break even. It's a lot faster doing these formulas than plugging in, cranking, and trying to figure out when we're going to get to zero. Questions? Clarissa, you seem like you're biting something, your nails or something. Were you? Or were you eating a snack? Okay, well, that's not bad to eat. It's better than your fingernails, though there's plenty of protein, they say, in your nails, along with hair. So if you really was kind of needing protein. All right. Am I going too fast? Sometimes I have a tendency when I know it to do too fast. Vincent? You got it? Okay.
Yeah, I got it.
Super.
Following along.
Good, good. You guys are doing the work. I complimented the class earlier, but not everybody might have been on. The best results we've ever had in this class since I've been teaching it here for, this is 16th year of teaching. You guys stepped up to the plate. You listened to the coach and you drilled those problems over and over. And were you able to complete it on time? I read it said about an hour, and you guys had what, 85 minutes? Wow. And most of you got it done right about 60 minutes. So by practice, you can get quick, can't you? If you're going to take the CPA exam, you got to know the problems that well that you could do it that quick. You got that, Greg? And others that are going to become CPAs? Practice makes perfect. The more you drill it, the faster you get. Deshante, you know what I'm talking about. Yes, it'll drive you to drink sometimes, but you're doing much better now, aren't you? Yes. Okay, any other questions or comments? Now we're done with A. How about B? What's the degree of operating leverage? What's the formula for that? Is it the contribution margin divided by the net operating income? Did I remember that right? Did you write it down in your notes? Nobody wrote it down in their notes?
I did.
What's it say in your notes, Greg? I'm kind of curious because you didn't get, when I asked for the total fixed cost, you gave me the total sales.
Right there,
Right? What?
there.
The degree of operating leverage? What do you have?
Contribution margin divided by net operating income.
Oh, so do we know both? Do we know both? Degree of operating leverage at last year's sales level. What's last year's sales level? Last year's sales level. What's last year? Can you tell me? Greg,
750,000
how much is it? 750,000.
sales.
Oh, so that's last year's level of sales, right? So what do we know? What do we know about net operating income at $750,000? What is net operating income at? $750,000 of sales.
Oh, net operating income is 90,000.
Oh, how'd you get that? Did it just pop in front of your eyes like a vision?
Yeah.
Ah, so 300,000 is our contribution margin, total fixed expenses, 210. and we subtract that, we do get 90,000, don't we? Oh, total variable expenses. And we get contribution margin, then total fixed costs. 90,000 net operating income. Oh, is it contribution margin divided by net operating income? Oh, is it? What is the contribution margin? Is it 300,000, Greg?
Yep.
Divided by what's the net operating income?
90,000,
So when you divide that, what do you get? What do you get?
3.33.
You do? 3.33?
Yep.
So what's that mean? If the company predicted sales would run up by 20%, what would net operating income go up by? Sales goes up by 20%. Not net operating income would be simply the degree of operating leverage times the increase in expected sales. It's not that hard then, is it? Multiplication. Okay, now,
Can you move your paper?
what's that? Yeah, you always want my paper, don't you?
I do. I'm greedy like that.
Yes. Do you like me writing on paper than writing on the board? Or do you like it when I'm writing on the board?
Whatever I can see, it doesn't matter.
Really? Okay. One thing about the whiteboard, I use color markers. Are you disappointed I'm just using pencil?
No.
It's kind of like exam day, pencil and paper. And then, but you got to type it in. Slow some people down. But if you can type faster than you can write, then it's an advantage. All right. Any questions or comments up to this point? Did we take care of requirement 1? A, break-even point in balls. We did that. B, the degree of operating leverage at last year's sales level. Okay. Now, in 2, due to increase in labor rates, the company estimates the variable expenses will increase by $3 per ball next year. If this change takes place and the selling price per ball remains constant at $25, what would be the new contribution margin ratio and the break-even point in dollars? Go ahead and calculate that. Go ahead and calculate that. I'm going to do it on my paper, but I'm not going to let you see it right now. I'm not going to let you see it right now. And I might even do something else like, oh man, let me find that. Just had it. Amazing. Yes, this is it. Okay, did anybody get that? Who could tell me what the increase in labor rate's gonna be? Vincent, did you get something?
Yeah, I got the contribution margin to come out at $7 per unit with a $3 increase on variable costs.
You're exactly right. Now, can you tell me what the percentage is? The contribution margin ratio or percentage?
Okay.
You got
Yeah,
the
so I got the 100% for the selling price and then 72%
for
and then
variable expense.
Yeah, and then contribution margin at 28%.
You got it exactly right. Exactly right. Anybody not get that? Vanessa? Are you gone? She's not there anymore. Just her
I got a sick baby. I'll be right back.
All right. Take care of the sick one. Ann, are you following along?
Yes, I am.
Excellent. Greg, I thought for sure you would have gotten it before this time. What happened? What slowed you down?
Everyone else a chance to answer first.
Oh, okay. Justin, are you grasping this?
I am. I just used the wrong numbers.
Okay. Colin, you're not there? Or that's a still photo. Oh, there you are. Oh, now there's movement.
I'm here.
Oh, is that your phone? Perfect timing. I called you on purpose. No. Conan, you get it? Are you getting it? Okay, you got to unmic yourself.
Yeah, I'm good.
Oh, okay, good. All right, I'm thinking everybody's got it. Everybody's got it. Okay, can we do the next one? Justin, are we ready to go to the next part of it, or you're good? Okay. All right, now let's see what it says. Refer to the data in 2 above. Oh, so that's what 3 says. You have to go back to 2. If the expected change in variable expenses take place, how many balls will have to be sold next year to earn the same net operating income of 90,000? So we got to use the targeted net income. The target, the new break-even point, if it goes to this, we're going to have to sell a lot more. 30,000 balls instead of 21,000. Wow. That's a lot more balls we got to sell to break even. Wow. See the difference? So that's why companies, when they have increase in cost, they have to increase their selling price, don't they, Greg? That's how it works. So if the government passes policies that requires cost to increase, like let's think of some, if they require everybody has to pay out a minimum of $15 per hour nationwide, even though the standard of living is way lower in Alabama, and it would equate to $12. That's going to hurt businesses to jack it up that much, right? So then their break-even point's going to increase. They're going to try to increase the selling price enough to cover and to maintain the same contribution margin ratio. And so if they can't raise it, then what they do is they have to cut some employees. And so maybe it sounds like a good idea. Everybody at the low rate gets a raise. But then what makes it kind of irritating for some is like, wait a second, they got a raise, but we're not getting any raises. That, the supervisor and other people that have been there longer, and their rates had to stay the same. So then there's animosity created because some government's interference, because we know that the price in Flagstaff's a lot higher than most of the state. And the marketplace does what? It automatically increases. Do you notice scarcity in Flagstaff, they have scarce number of homes for sale. So homes are selling. I had a former student said their parents got $100,000 more than they were asking because very few houses in Flagstaff are for sale. Scarcity. Wow. And what happens to rents in Flagstaff? Have they been going up? I think I saw somewhere the average one bedroom is $1,500 a month. Wow. Whew, that's tough. Anyway. So 3, did anybody get the answer to 3 yet? We have to use the same data in 2, Justin. If the expected change in variable expenses take place, how many balls have to be sold next year to earn the same 90,000? So use the targeted net income of 90,000 plus the total fixed cost and divide it by the contribution margin per unit. That should give us what they're asking for. Let's see, let's double check. What are they asking for? How many balls? Oh yeah, how many units? So shouldn't you take $90,000 as the net operating income and add it to the total fixed cost? Can you tell me what the total fixed costs are, Justin?
210,000.
So that didn't change. That didn't change, did it?
No, just the variable cost because they raised the labor costs.
So what's the variable cost? Oh, but they want to know how many balls do you have to make to sell to get the same targeted net income of 90,000. So would you take the 210 total fixed cost plus the net operating income of 90,000 last year? That'd be 300,000 in the numerator. But now what number are we going to divide it by? What's the denominator? The cost, that would be the contribution margin per unit or per ball. What is that now?
It's now 28%.
So that would give us total sales to achieve that level. Is that what they were asking? Let me read it again. Refer to the data in 2. If the expected change in variable expense takes place, how many balls? It didn't say how many dollars sales they need to reach. How many balls? So you use what's that?
Then we use the $7.
Yes, you have to use the contribution margin per unit. So you're going to have all kinds of problems in the quizzes, on the exams, in the homework problems, and you got to read the question. What are they asking for? In units or in dollar sales? And in this one was obvious. They wanted to know in units, right? So how many balls would you have to make then to cover that $90,000? How many would you have to sell? Justin, no answer?
It's a weird answer. It's 42,857.
Anybody confirm that number?
That's what I got.
That's exactly right. That's exactly
That's
right.
Yep.
Yes, you got that many balls now that you got to sell. That's a lot more, isn't it? You got to do more work. Oh, man. So if you have to make more balls, what's all the costs involved? Not just paying employees, right? One time I was running the state junior high wrestling championships, and I said to myself, there's going to be lots of people here. They're going to want lots of drinks. So I ran to Costco and bought cases and cases of pop. And I was saying to myself, back in the day, that was, let's see what year that was, because you got to put it in perspective. Because of inflation, back then, you can buy a can of pop, 12 ounce, for 75 cents. And you can also probably buy it at around 50 cents a can, depending where you're getting it. Oh, but if you're getting it at Costco and you're buying in the caseload, you can get the cost way down, right? So then I said, do we want to sell it for 50 cents? the machines outside the building, they're selling it for 75. We're going to sell it for the same price. Guess what? We sold fewer cans that year compared to last year when we were selling it at 50 cents, but we made more money profit. Because our profit margin went up. So did we have to make less trips to Costco? Yes. We worked less, but made more money, even though we sold less cans of pop. So those are the kind of decisions you'll make. Yes. See, I applied this knowledge to this little wrestling tournament. Well, it wasn't so little. The place was packed and we made a pretty good profit. What did we use the profit for? For Connect's car? No. All the profits went into the program. We were able to buy new warm-ups and et cetera, and other things that we needed to run that wrestling program at that high school. Anyways, there we go. Everybody sees what happens when things change. And these are the things as a manager, if you know things are going to be changing and you're going, hey, we're going to have to sell a lot more units just to keep the same targeted profit. So what they're going to try to do is raise the selling price if they can. That's the first thing. If they can't do that, then they're going to be looking to ways to cut costs. Can we try getting the job done with fewer laborers? So there's all kinds of repercussions when prices change for costs. Because if you can't stay competitive in the marketplace, it's pretty harsh that you lose, and you lose revenue. And if you don't have enough revenue to cover costs, then you're eating losses. And most people can't stay in business very long with losses. Okay, any question with 3? Okay, now we're moving on to 4. And we're running out of time. Refer again to the data in 4. You know what? Before we run out of time, I think we better look into the appendix, because I can always send you the solutions for the rest of problem 520. 520. So we're going to look at the appendix. And this has to go back to mixed cost. Remember mixed cost from chapter 1? Remember I told you all the costs that they defined in that first chapter you're going to have to use through the whole book. So what is mixed cost? Who can recall what mixed costs are?
It's a combination
Yes, it is a combination of what?
variable and fixed.
Variable cost and fixed cost. So that's why they call it mixed. Mixed cost. In the appendix, and let's see, starting on page 241, analyzing mixed costs. There's 3 ways to separate out the fixed versus the variable cost in a mixed cost. You can use a scatter graph plot like they do on page 243. So again, you can use graph paper. The scatter graph method is more of an estimate because you're going to have to draw a line that best fits all those dots. So you're going to have to kind of draw a line where about half the dots are above and half are below. That's not easy when they're kind of scattered like that. The second way is use the high-low method on page 243, and then the least squares regression method on page 245. How many people use the least squares regression method in statistics? Or haven't you had your statistics class? Justin, you had your statistics class, didn't you? Oh, you haven't yet? Wait until you
I'm in college algebra right now.
college algebra, all right. And then you have statistics, you got finite math, and then calculus if you're going to major in accounting. Is that true? Greg, you know that, didn't you? How about Colin?
No, I didn't take statistics.
Haven't taken it? No one's taken statistics yet?
I'm
Students?
taking it this semester.
Yeah, I'm
Oh,
taking it this semester.
did they start talking about least squares regression method?
Not yet.
That's the most accurate method. Do you see that on page 245? When I took math, we had simultaneous equations. Did you have simultaneous equations? We had it in high school even. Yes. There it is on page 245. You got B. You know what B represents? That represents the variable cost per unit of activity. A represents the fixed cost. And you got two simultaneous equations where you got to take N, the number of observations, times the sum of X, X meaning the level of activity, that's the independent variable. Y is the total mixed cost. You multiply that together and add it all up. And then you subtract the sum of X times the sum of Y over N being the number of observations times the sum of X squared minus the sum of X squared. Oh, it is crazy. And then you take that equation and you have to subtract A equals the sum of X minus B times the sum of X over N. That's crazy, that simultaneous equation. But now they have computers where you can plug it in. You don't have to use simultaneous equation. But I used to make my students use those two formulas. You had to memorize them and you had to work it all out. Who still wants that kind of a challenge?
No, thank
Ken, are you open for that kind of a challenge? But no, because of computers, that's right. I can read your mind. I can read your mind, Cherie. You're not interested in memorizing those two simultaneous equations and figuring it out the old-fashioned way. So we're going to let the computers use the least squares formula, but we're gonna work on the high-low method. That's what we're going to do in this problem 5A-3, I think I had for you. Yes. Let's go to exercise 5A-3. That's after the appendixes they talk about. It's probably a good idea to read that about mixed cost, especially Greg, because when he gets to the big university, they're going to expect that you know that stuff. So on page 250, that's where exercise 5A-3 is. We got this Transport Limited Company operates a fleet of delivery trucks in Singapore. The company has determined that if trucks driven 105,000 kilometers during the year, the average operating cost is 11.4 cents per kilometer. If a truck is driven 70,000 kilometers during the year, the average operating cost is 13.4 cents per kilometer. Using the high-low method, the estimate variable cost per kilometer and the annual fixed cost associated with the fleet of trucks express the variable and fixed cost in the formula Y equals A plus BX. Y equals the total cost, A is your fixed cost, and B is your variable cost per unit. X is the number of units. If the truck were driven 80,000 kilometers during a year, what total operating costs would you expect to be incurred? So so you gotta use the formula to determine the fixed cost, mixed cost formula. So how do you do that? Well, turn back to that page right there. In the high-low method, you have to know the rise over run. And you take the total at the high level of activity. You look at the lowest level of activity. You look at the activity. And if you go to page 244, their activity is patient days. We can update this problem and say COVID patient days, COVID-19 patient days. So they had 8,000 in June being the highest level of activity. The lowest level of activity was March, 5,000 patient days. The change is 3,000. The difference is 3,000. The cost at the high level of activity of 8,000 patient days, it cost us $9,800. At the low level, 7,400. The difference being 2,400. So you take the difference in cost and you divide it by the difference in patient days, the rise over run. So it's 80 cents per patient day. That becomes your variable cost. Then you could take either the high or the low point. So that means in this example on page 244, 8,000 patient days times the 80 cents. That would be the total variable cost. You subtract it from your total maintenance cost and you can arrive at total fixed cost. And if you did it at the low level of activity, you take 80 cents times 5,000 patient days. That'd be your total variable cost. You subtract it from 7,400, and guess what? You would end up with the exact same total fixed cost. That's how you arrive using the high-low method. So now you can be able to do, and I'll send you the solution since we've just now run out of time. So I'll send you the solutions for the rest of 520 and for 5A-3. All right, on the sales mix, you're just going to have to use the example in the chapter. There's just too much to cover and then to go over examples. So I do the best I can. It's a lot of material and you guys are doing a good job at mastering it. I was doing backflips when I saw the results. So yes, when only one person fails, and the reason they probably failed, they joined the class 2 weeks late, they're in a hole to try to learn all of that stuff, you know, in the 2 weeks that we had to go for exam 1. All right, so I'll stick around for the next few minutes. People might have questions about the exam or other questions about the material. I'd be glad to help you out. Until next time, you guys have a good one. We have 3 problems that we have one out of the appendix. I think it's 5A-7. And when we got, I think it was 21, 25. Oh, wait. Might have been, I can't remember the exact numbers, but it's there in the assignment tool.
21, 23, and 25.
Yes. Besides problem 5, is it 5A-7, I think. Is that right?
Yep.
Okay, excellent. Okay. Any questions about the material or about the exam you took and everything? Deshante, you did very well. Proud of you too. You did a good job. Nobody has questions.
I was actually curious when the answers would be posted for the exam.
And who's asking me that question? I can't tell.
Oh, it's Jasmine. It's me.
Oh, Jasmine.
Mhm.
So what I'll do is I can set up a Zoom and go over your exam if you want, but I wasn't going to post any answers because I might use some of those questions for the final.
Okay. Yeah, we could do a Zoom. That would be great, actually.
Okay. Is tomorrow a good day for you?
Not tomorrow because I have class, but Friday before noon would probably be good. Yeah.
Do you, I could go over it after everybody else asks their questions if you have a little bit of time today.
Today I don't, but Thursday would work.